Hey guys, Mr. Buendia here, and I'm working through the problems on page 37, which is a review for your next test. So you may see some questions like this on your next test, all right? So I'm gonna start with number 3. I've worked numbers 1 and 2 out at the very end. They're not really applicable to what we're doing right now, but I did go ahead and work them out in case you wanted to see the solutions. Those are at the very end of the video, okay? All right, so number 3 says, given a point 715, determine the exact values of the 6 trig functions of theta. Okay, so whenever I see problems like this, I like to start by drawing my diagram first. So here is my coordinate plane. 715 looks to be in quadrant 1, 7 units, 15 units back to the middle. 7, 15. And we're going to need to solve for r. So remember your formula, x squared plus y squared equals r squared. That's Pythagorean, right? And we're going to solve this by plugging in our x and y numbers, 7 squared plus 15 squared. Put some parentheses, good habit to be in. Okay, and we're going to start solving this. So 7 squared and 15 squared is 49 and 225. And that's going to give us 274 in the value for r squared. So after we've got that, we have to take a square root of each of these. So here's our square root sign, okay? And that does not actually simplify any further. So we've got r equals square root 274, okay? So now that we've got r, we've got x, y, and r, all three possible values, we're just gonna go to the sines and cosine definitions, right? X over r, y over r, so forth. And we're going to go ahead and plug everything in, okay? So cosine theta is x over r. And if I plug that in, I'm going to get 7 over square root 274, okay? Now, we don't leave our answers in this form. We're going to have to rationalize this. So I'm going to multiply by root 274 on the top and the bottom. Okay, and so what that means is you're going to finally have your final answer. Let me bring it down here. And it's going to be 7 square root 274 over 274. Okay, so with that answer, we can now go ahead and find the other ones. They should all kind of follow the same concept, right? Look at the definition and then plug in the numbers. So I'm going to start with sine. So we've got sine theta, which is going to be 15 root 274 over 15. Tangent theta, which will be 15 over 7. We've got secant theta, which will be square root of 274 over 7, cosecant, which is root 274 over 15, and cotangent theta, which is 7 over 15. Okay, so guys, we just took the numbers and we plugged them back into definitions. That way we get all of the versions. Watch out, guys. The ones I'm going to mark here are going to be the ones that have to be rationalized. So I'm going to just use blue here. So if you see a blue star, you know that that's going to be one that was rationalized. Okay, those two are rationalized. Okay, remember we can't leave roots at the bottom. We always fix them so that they are at the top. Okay, so now we can take a look at number 4, which says state the quadrant in which theta lies given the restrictions below. So it says cosecant theta is greater than 0 and cotangent theta is less than 0. Okay, so let's take a moment and just think through these restrictions and see what we can piece together. So the first one is the cosecant theta is greater than 0. So cosecant is r over y, which has to be greater than 0. And based on this, y is the only number that can be positive and negative. R is never negative. Okay, so I'm just going to make a note about that. Let's keep track of that. Okay, this is never negative, and that's for R. Okay, so just something to remember. R is your hypotenuse of the triangle, and it's never negative. It's just always a number. So in this case, we know that Y, which is my bottom number here, that is actually a positive. Okay, so now that we've noted, hey, Y is a positive number, okay, I know that on my graph, I'm going to have to be on that top half, okay? So I can kind of just say, hey, let's eliminate 2 of these. So these are out of the question, okay? Just because Y is positive, all right? Let's look at our other piece of information. Cotangent is less than 0. Now, cotangent is x over y, and it is less than 0. Remember, guys, that just means that this is negative, all right? So now, knowing that this is negative, I'm just going to backtrack. I'm going to say, hey, like, look, I already know that y is positive, right? This is positive. And in order to get a negative answer, x has to be negative. So having said that my x is negative, I know that I can no longer be on the right-hand side, okay? So we can eliminate 2 more quadrants, right? Which basically is this way. So what's left? My answer must be in quadrant 2, right? So this is my good quadrant, which is quadrant 2. All right, so the answer to this question is that this angle is in quadrant 2. Okay, logically think about the information that they give you, break it into pieces and say, hey, which must be positive, which must be negative, okay? Keep in mind that if you have 2 things that can be negative, right, like x and y, they can both have negative signs and cancel out to make a positive answer. So we needed both pieces of information together to really get this down, okay? Okay, ladies and gents, let's do number 5 now. So this says, find the values of the other 5 trig functions of theta under the conditions that are following, right? Cosecant theta equals 4, and cotangent theta is less than 0. This is supposed to say and. Yeah, I think it reads really badly right now, but just remember these are 2 separate statements. All right, let's start with the first one. Cosecant theta equals 4. Well, what is cosecant, right? It is r over y. Okay, so if I say r over y equals 4, and I'm going to go ahead and pretend this is a fraction. Let's just play 4 over 1. I can very easily justify saying this. R is 4 and y is 1. Okay, very simple justification. If you have it already as a fraction, top becomes r, bottom becomes y. But very simply, we just need to figure out what r and y are. Okay. With this information, I'm going to use my Pythagorean theorem. Okay, so we're going to take this, and we're going to use Pythag, and that will be x squared plus y squared equals r squared. And let's just plug in what we know. X squared plus 1 squared equals 4 squared. And if I solve this, equals 15. So x equals the square root of 15. Okay. Now, here's the other handy piece of information. Okay. I've got the cotangent over here is less than 0, right? And my y is already positive. So if I told you cotangent theta is less than 0, that is x over y is less than 0, I once again am going to determine that x is negative. All right, and knowing that x is negative, I'm going to go ahead and add my negative sign right here as well. Bam. All right, so now, once again, I've got x, y, and r all solved for, and I'm just going to end up plugging those in where I know those definitions are. Okay, so let's go ahead and start filling this in. We'll start with cosine theta, which is going to be negative root 15 over 4. Okay, sine theta, we're going to end up with 1/4 tangent theta, which will be negative root 15 over 15. Okay, and then we can get the other three, the reciprocal versions of these, which is going to be secant theta, which will equal to negative 4 root 15 over 15. Okay, we've got cotangent theta is equal to negative square root 15. And it's actually over 1, but we don't need to write that. Okay. Once again, I'm going to mark, hey, some of these have been rationalized, like this tangent. Tangent's definitely been rationalized, so has the secant. Okay. So those two are rationalized. All right. So if you're not sure, hey, this one and this one, we're both rationalized. Okay, so answers should always be in their simplified form and rationalized. We reduce our fractions and we rationalize. All right. All right, so next up is number 6. Okay, so number 6 has some tricky parts to it, and I'll try to make sure I point those out to you. Okay, but it's all about finding reference angles. So if you don't remember, a reference angle is basically an angle that's going to form the same shape as the angle given to you, except it's going to be only in the first quadrant, okay? And the best way to find the reference angle is just to think, hey, how can I get back to the x-axis in the shortest distance possible, okay? So I'm going to do the first one. The first one's pretty straightforward, I think. Here's my quadrants, right? This is A. My quadrants, and if I draw my angle, I'm going to start from standard position going around, and I'm going to end up somewhere in quadrant 4, right? This is 322 degrees. Okay, and if I want to continue on and get back to the x-axis, I don't want to go left. I would much rather finish my circle and go this way, right? So this blue piece is my reference angle, all right? How am I going to find how big that angle is? Well, if I had gone all the way around, that would have been 360. And what I can do is I can take the 360 and just subtract the 322 degrees that I've already gotten. Okay, so once I've gotten that, we can just solve this for the answer, and you should get that it is 38 degrees. And that, ladies and gentlemen, is the reference angle. Okay, so that is the ref. We'll just put that. All right, so the idea is, again, draw a picture and then just figure out how can you quickly get back to the x-axis. Don't go to the left, that's the long way. You take the shortest path to that, okay? So I'm going to skip B for a moment. I'm going to come back to it. B is a little bit tricky because it's got a bit of a trap to it. C is a little odd as well, but it's a little bit simpler than B, okay? So here is part C. Now, the trick with this is actually in radians. Even though it has no pi's in there, it's actually in radians still, okay? So we're going to solve it the exact same way we would if a problem with radians, all right? Let's draw our quadrants, okay? And I'm going to go ahead and label it this time just because we're not as good with radians as we are with degrees. So here's pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and we could even come up with decimal estimates for that if we wanted, especially if we're struggling to kind of see where that angle is. All right, so 2.72 is more than half a pi, but less than a pi. This would be about 3.14. This is about 1.56 or 1.6 something. Okay, so I'm just going to go around. And that's my angle right there. Okay, that is the 2.72 radians. All right, and I want to get back to the x-axis. So take a second and just think, which way should I go? Left or right? Okay, I'm hoping that you've come up with going to the left this way, okay, which reaches to pi, okay? So what I'm going to do is I'm going to take pi, and I'm going to subtract 2.72 from it. Now this time we don't have exact numbers, so we're actually going to end up using the value of pi, 3.14159, whatever it is. And you can approximate a little bit, and you'll get that this is about 0.42 radians, okay? So again, what we've done is said, hey, this is approximately 0.42 radians. It's not exact because it's not in terms of pi, but we do have a reference angle, which is 0.42. Okay, guys, so let's go ahead and do B as well now. So B is kind of a funny one because 15 pi over 6 is actually not the best form for this. If we reduced it, we would actually get this as 5 pi over 2. And a lot of people will notice, wait a minute, this is not even on the first rotation. It actually goes further around the circle. And because this goes further around the circle, that actually makes this problem more complicated looking than it is. Okay, so one thing you could do, you could find a coterminal angle in the first revolution and then solve the reference angle. Okay, that I think is the safest way, but it is kind of cheating because you're not using the same angle. Okay, let's go ahead and draw our diagram and just see how this ends up working out. All right, so again, here's pi over 2, a full pi, 3 pi over 2, and 2 pi. So 5 pi over 2 now is actually going around the circle 1 half, 2 halves, 3 halves, 4 halves, and 5 halves, right? So it actually goes, you can see that it's making a spiral. It's actually crossing beyond the first rotation, okay? But let's just kind of follow the same idea through this whole part as we did earlier, okay? So we've got our angle, and I want to find my shortest distance back to the x-axis, okay? So that distance actually is either from here to here, or we could go the other way, all right? So we do need to figure out how big this red angle is. That's the one thing I'm looking for. And if we just think about the circle, we could do from 0 to pi over 2 and just say, hey, this means that if I subtracted this 2 pi from here, you would get that this is pi over 2. And this is actually not really a reference angle. And everyone's going to go, wow, you made me do all this thinking for the fact that it's not actually a reference angle. And the reason for this is not an acute angle. And reference angles are always positive and acute. So we can say this is not a reference angle. And basically, that's just a trick question thrown there to throw you off. If you ever get something like this, you could solve it, and it would give you something that looks like a reference angle, but it's not an acute angle, so I wouldn't say that it's really a reference angle. All right, guys, we're going to pick up on number 9 now. Numbers 7 and 8 are not really applicable to what we're doing right now, so we're going to actually just straight skip over those. So number 9 says Patrick is riding a racing bike at a speed of 50.4 kilometers per hour. The wheels have a diameter of 70 centimeters. Find the angular velocity of the wheels in radians per second. Okay. So we want to calculate the angular velocity. Remember, that's this omega, right? Some people call it a W, but it's an omega, all right? And the best formula we can use for this is going to end up being V equals R times omega. Okay, the reason is because we know the velocity or the linear speed, which is 50.4 kilometers per hour. Okay, they went ahead and told us that in the problem right there. Okay, and we're going to find the radius based on the fact that they told me that the diameter is 70 centimeters. Okay, so we're going to use this information to help us solve this. The easy part is the radius. R is just going to be 35 centimeters. That's just 70 over 2. All right, in case we didn't catch that. All right, now we need to make sure that we use the same units. This won't work if we're not using the same units. So the best bet is let's make everything into centimeters, because if we tried to make 70 centimeters into kilometers, that would be a really, really small decimal, and decimals kind of suck. All right. So I'm going to use dimensional analysis to change this into centimeters, and I want to be per second because I asked about my final answer in seconds. All right. So let's go ahead and fix that. We're going to use dimensional analysis. So 50.4, and this is kilometers. And we're trying to change from this per hour into seconds, okay? So I'm going to start by actually changing the time unit. Time is very easy. So 1 hour, matching this up across from each other, is 60 minutes, and 1 minute is 60 seconds, okay? You can use that 3600 conversion if you want, but I like to just go each unit one at a time. It makes more sense to me, all right? And let's go ahead and fix our meters as well. So I know that kilometers, 1 kilometer, okay, 1 kilometer is 1,000 meters. And each meter, so 1 meter, has 100 centimeters in it. Okay, so let's just check that our units all worked out. So I'm going to start from the bottom. This hours cancels out with this hours. This minutes cancels out with this minutes. And I'm left with seconds at the bottom. That looks good so far. Kilometers will go away, meters will go away, and I'm just left with centimeters over seconds. That's the unit I want, okay? If we multiply all of this out, right, 50.4 times 1,000 times 100, and divide by the 260s, you should get that we have 1,400 centimeters per second. Okay, great. Once we've got that centimeters per second down, we're just going to end up plugging it back into this formula up at the top that we came up with. We already know our radius, and we know now the velocity, so we've got 1,400 equals 35 times the angular velocity. If we divide this, we will get that 40 radians per second is the angular speed. All right, guys, now on to number 10, another angular velocity type of question. And it says there are two pulleys that are hooked up together, a small pulley that's 6 centimeters in diameter and a large pulley with a 15 centimeter diameter. And the small pulley is turning at 120 RPMs. Find the angular velocity of a small pulley in radians per second, and find the linear velocity of the rim of the small pulley, okay? Don't let that of the rim part throw you off. We're just talking about as if the pulley is as a whole, not as anything smaller than that, okay? So I already know that the small pulley is turning at 120 RPMs. I can just convert that into radians per second, okay? So 120 revolutions in 1 minute, and we'll use dimensional analysis again. That's our little train tracks, okay? So we need to change minutes into seconds. So we'll just do that. We've got 1 minute is 60 seconds, okay? And we need to change revolutions into radians, okay? So guess what? 1 revolution, remember that's 1 complete trip around the circle, is 2 pi radians, okay? Let's check our units. Let's make sure they all cross out the way we want. Minutes have gone away and I'm left with seconds. That seems good. Revolutions go away and I have radians on top. So radians over seconds, that looks good to me, okay? So if we multiplied this all out, and I'll go ahead and show you the math. 2 pi times 120 is 240 pi over 60 seconds. And this reduces down and we should get 4 pi radians per second. Okay. And now that we've done that, that's the answer to part A. And now we can focus on part B. Now part B says, can you find the linear velocity of the rim of the small pulley? Okay, so again, small pulley, same one that we were looking at earlier where it's 120 RPMs. We've got that angular velocity. Let's use that same formula that we were talking about earlier. So here was the answer to A. Let's go ahead and do B. B says find the linear velocity. We're going to use that same formula we did earlier. V equals R times W or omega. Okay, and let's just plug the numbers that we know in. R is going to be actually 3. Okay, watch out for this. Remember, R equals 6 over 2, which is 3. And this is actually my omega. So let's go ahead and plug these numbers in. V equals 3 times 4 pi, or just 12 pi. And this is going to be in what unit? We've got centimeters, and we were in per second, so we're going to be centimeters per second. All right, guys, and so as a bonus, I'm going to go ahead and be working out problems 1 and 2 from this page. Now, these aren't super relevant to what we're doing in this unit, but it's still some good knowledge that you should, in theory, have from geometry. So follow along and see if you remember how we do this, okay? So we're talking about Isaac who's out camping and he wants to hike a mountain, all right? So according to this, Isaac's camp is 5,280 feet or 1 mile from a point directly below Mount Monadnock. I can't say that anyway. What is the hiking distance along the ridge if the angle of elevation is 25 degrees and 16 minutes? Yeesh. They threw us a curveball by making this unit kind of funky, but it's not something we can't handle, all right? So first thing, let's draw a picture. Here's my triangle. 5,280 feet from the base of the mountain to the campsite, okay? So here is his camp, okay? And this side right here is the mountain. All right, and that is the name of the mountain that I cannot say, so I won't try anymore. All right, and this right here is my angle of elevation. And let's just note theta is equal to 25 degrees and 16 minutes. All right, and in order to convert this, remember guys, we would take the minutes and we're going to divide that by 60. All right, and it would give me either a decimal or a fraction, and you get 25 degrees and 4 out of 15. Or we can make it a decimal and you would have 25.26, and that's repeating degrees. Okay, either one of those is fine. So we just need it in decimal degrees because our calculators will operate our trig in that form. Okay. Okay, so now we can set up a trig ratio using that angle and the information that we know. All right, so if I wanted to label it using the old school terms, we could call this the hypotenuse, the opposite, and the adjacent. We could also call these x, y, and r in the new way of looking at it. Okay, same thought process, just different setups for it. And so we set up the cosine, because I do know the adjacent and I want the hypotenuse. So cosine of the angle 25.26 repeating degrees, and that is going to equal the 5280 over my hypotenuse. And if we do some algebra, we move that hypotenuse to the other side and we divide by that cosine value. We can solve and get that the hypotenuse is equal to 5838.57. And this is going to end up being in feet, just like my other unit. All right, so we've solved part 1. We've actually calculated out what the hypotenuse is. Let's figure out now how much higher in feet is the top of the mountain than his campsite. So this was part 1. Let's go ahead and do problem 2. So I'm going to kind of push it off to the side. And problem 2 is actually just asking us, hey, can you calculate the opposite? So exact same diagram, exact same triangle, but can you calculate the opposite side or that y value instead? And I'm just going to use the tangent in this case, okay? So tangent of the same angle, 25.26 degrees, is going to equal my opposite side over 50 to 80. Now, some people ask me, hey, why not use the sine or something else? You now have the hypotenuse. You can use that. Okay, the thing is, because we rounded our hypotenuse number off, we don't want to do that. We might lose a couple of decimal points somewhere. Okay, so it's always better to rely on the numbers that were given to you. Okay, and if we were solving this one out, remember we just take both sides times 5280 times 5280. These cancel out, and that gets me the opposite by itself, or the y value by itself. And we should get that this equals 2492.087, it looks like. And that is in feet. Okay, so his campsite is 2,492 feet shorter or lower than the top of the mountain. Okay, he is 5,280 feet away from the point under the mountain, and the hike length would have been that 5,838.57 feet. Okay, great. Good luck on your test later, guys. Thank you for watching.